This is lecture number 15 for peer-to-peer MOOC. In this lecture, we will be looking at a problem which happens when the key and value pairs are stored at various root nodes. So, when I have a network and there are various nodes in this and they are being configured in a DHT format. So, a key value, when it is published, this key value will go and reside with some root node. Now the problem is, this root node, the way we define is that there is no other node which is better than this. Therefore, this guy has the responsibility and it will maintain a database where key and value pairs are going to be stored. But when some new node comes in, what is going to happen? So it is possible that new node is a better choice for this key value pair. So if this new node would have been there, and when the search for the root node of the key was done, I would have ended up at this new node. So this new node is, for example, appearing here. So I might have ended up here actually. But now the values are being stored here, and when somebody wants to search for it, he will end up in always coming here and there is no entry here. So how to take care of this situation? So new node joining in is one of the problems. And of course then suddenly this node goes away. So with that, all the entries which are saved here, these are also lost. So when these entries are lost, but the entries should always have to be there in the DHT network. That's a condition on which the peer-to-peer network are going to work. So I need to have some mechanism by which ensure that some other place also the entries are available, and whichever is now going to be the new root node. So because of this new node coming in, so this had become the root node, but if when this was not there, this guy was the root node. So the entries should now move, all these entries should now move back to this guy. So how this will be done? Okay, so now roughly the way that it happens is, you always take a key, you compute the hash of this, and then you are now searching for the root of this. That is the procedure which is followed. Okay, now this root node has to be moved to some new place. So we can actually see it through an example when how this is going to happen. So how this guy will figure out that I need to move, or I need to move it to, there is a new root node which is feasible. So the hypothesis which we have is that every root node will have a routing table. Okay, and normally what happens is, how the root node identifies that it is the root node? It takes the key value, again the key here, computes the hash, and it then tries to find out the root node by trying to root this. This is the hash ID. So this hash ID is going to be used by this node to look into this is a routing table. And then from this it will figure out that this itself is the best possible choice still. That's why it is a root node. That's a test which is done everywhere. So if there is going to be some local routing table change, then only it is possible that somebody else can be the root node. So when this new node comes in, so the change in routing table should happen at all the nodes whose some of the entries at those nodes, if they are supposed to come to this new node, then in all those places the routing table update should be happening because of the addition of this new node. That is a hypothesis, and this is exactly how this actually should be done. So for understanding this, let's now do an example. So the example is, so we take a node number, certain nodes here. So I take a node which is going to be 0, 1, 2, 3. I take another node, I give it a number 0, 1, 3, 2. Then I take another node A0 to F. I take another one So I am just going to write all of them down which I am taken. I have taken them arbitrarily, and then I will try to find out what happens when a new node enters. So ultimately we end up in having these nodes. And let's also find out what hash ID I am looking for. So I am looking for some key value pair. So it can be either publish or it can be a query. I am taking this key, passing through a hash function. I will get the hash ID. So hash ID which I am choosing now, let it be 0443. So with this hash ID, let me do the example. So currently the node list which we have is only possible nodes which will match with the first ID is 0. So this actually means only one of these two has to be there. So who is going to be there? So let's now compare 0443, and I have a choice of 0123 and 0132. So first digit is matching. So I need to go to the second one, but second one is only this one as an option. Okay, so there will not be 4 has to essentially go to any one of them. So let's now match with the second one to decide which one it will be going. Okay, so 3 and 2 are the only two numbers which are available. So if I draw, so 2 is going to be here and 3 is going to be here. So 4 will lie after this. So which implies when I am going in this fashion, so there will be somewhere a 0 will be going to be there, but there is no node with that, 1 and so on. Okay, so 4, 5, 6. So this is actually I am taking hexadecimal digit here. So in this example, let me, okay, I should have stated that I am taking the one with the 4-digit node ID. And each digit is hexadecimal digit. Okay, so that's the case which I am taking. So for 4, the next higher node is going to be 2 in cyclic fashion because I am going clockwise. So 0, 1, 2, 3 obviously will now be the root node for this. So for 0443, if I have to find out the root node for this is going to be 0123. So 0123 is going to have a local table where the database is going to be there, is an index will be there. There the key and value will be stored. So key and value will be stored here. Now let's see what is going to happen if I introduce another node. So let the new node which is going to be introduced is going to be 090F. So that's a new node which is coming in. And with this new node, we can clearly see that 0443, if I am going to talk about the second digit, so now we have an option of 0443. So 0 digit which are matching are only with these two guys, 0132 and 090F. So in this case, this I have to figure out. So in the second digit, if I actually make a circle, it will be 1, there will be 9, the 4 will be coming somewhere here. This is not a node, this is a hash ID. So obviously this 9 will be responsible. So 090F has to be the root node for this. So is the routing table for 0123 changing? 0123 originally is the root node. Is the routing table changing? So let's look at that. So 0123, the routing table will look something like this. There will be 3 rows and 4 columns obviously. So 0123, you have to look at all the nodes. So which node I can actually put here. So after 0 there is an only closest one is 1, so we have an entry with 1, so I can write 1045. So this is obviously, you can actually see 1045 is available here, so I can actually take this whole thing down for simplicity. I should write 1 here. So 1045 will come here, which is the next entry. Now what is going to be predecessor? So what is lower than 0 in cyclic order? So you have to take 0. So from 0 you go to 1. And then of course there is full circle. So who is going to be the node which is going to be closest here? So in this case, this is DD0F which will come. So I need to put DD0F. And now again, yeah, I should have commented that the routing table structure which I am using is for tapestry hybrid, which I had discussed earlier. This is what we have been using in our B4 system, which we are designing, working upon in my lab. And then of course, what will be the entry which will come the midway. So in 0, I can add whatever is a half value of 16, which is 8. So I will end up I have to get something with 8xxx. We do have an entry here with 8045, so that will come here. Okay, now what will be the next entry? So this is, now let's look at this table is when 090F is not there. So this is before node addition. So in this case, there is only both entries which are actually starting with 0 or start also having 1. So I need to put an entries which are different than 1. So anything which is higher than 1, so 02 could have been there. So it means these all will go vacant. So the third entries where 01 are going to be there. Now after 2 the 3 comes. So 01, 32 will be available as a successor. There is no other entry, so the same thing will also become predecessor in that loop. Okay, is for the third digit the ring is there. It's for that predecessor, successor and middle for the third digit. Fourth digit there is no match. There is no node which is going to be there. There is nothing with 0, 1, 2. So it's going to be dash. So this is the old table. Now what happens when 090F will come into picture? So it will essentially will now connect to somebody who is going to be the bootstrapping node, and with that it will keep on exchanging, and ultimately the routing table will get updated. So what will get updated in 0, 1, 2, 3? So if you look at 090F, it matches with 0, 1, 2, 3 in the first digit. So entry has to go in second column. Second column there is no entry because there is no other node which was having a different second digit than 0, 1, 2, 3. So there was nobody with 0, 2, 0, 3 and so on. So now 090F does come. So this will become predecessor as well as successor. There is no other option. So we can actually clean it off and then do it. So this will become 090F. This will also become 090F. Okay. So once this happens, immediately 0, 1, 2, 3 now is figuring out that routing table has changed. And once routing table has changed, it should now republish its own entry. So now it should republish its own entry. So where the entry will be going? So it has to now essentially 0443. It will be searching for the best match here. So 0443, 0 first digit is matching. So it has to go to second column. So now you have in the for second digit, this itself is going to be 1. And there is an entry 9 which is available. So 4 has to be now placed. So 4 is somewhere here. So for this, the node will be now 9. So it will just hand over 0, 1, 2, 3 will now hand over the query to 0904. So the whole entry will now be moved there and it will be a publish request. So when it goes to 090F, 090F will also have its own routing table, which will get created over time and it will be stabilized entry. So what will be that entry? Let's see. So again it will be a same 4 column and 3 rows for 0904. 090F, sorry. The first digit, first column can be as it is, which is going to be there 1045. There is no other option. If there would have been more than one option, the one which is closer would have been actually picked up in this case. Okay, 8045, then you have DD0F. The second place, it will now have only possibility 0, 1, 2, 3 and 0, 1, 3, 2. So 0, 1 is the only option. So 0, 1, 2, 3 or 0, 1, 3, 2, any one of the two could have been there. So it will be keeping this. There is an alternative. You can actually keep 0, 1, 3, 2. So this one also will be, in that case, will be 0, 1, 3, 2. So these are the two possibilities. So either this or this will be there. There is no middle entry. So when 090F is going to search for the best possible node for 0443, which we are searching for. So let's look at above. That's what we are looking for. We are looking for this 0443. So 0443 now. So hash ID is 0443. So 0 it is going to match, go to second column. Now you have 1 and 9 only which is available. It will also look at this particular arrangement, and 4 is going to be closer to 9. Okay, that's how we defined in the tapestry. So ultimately it end up in 090F. So 090F has received this entry. It will now put its own index. It's going to maintain an index. It will put that entry. It will put that entry in the index. So now the key value is going to be updated. Now, of course, in this mechanism, there is a problem. So 090F might come, if I look at a timeline. So at this time, 090F appeared. Okay. So then, of course, the entry got updated, and 0123 has given it to 090F. Now, should 090F should immediately remove it. Now there is, I am actually also assuming that each node also maintain a backup mechanism. So if it fails, we are going to look at this backup mechanism after in the next lecture. So if it fails, the backup mechanism comes into picture. You have given your entry to 090F, and now 090F has not created the backup so far, and it fails again. It goes off. So backup is not there. You have already purged your entry because you are no more the root node. Entry is lost. Now it comes back again. There is no way it will be able to recover the entry. Now this is not desirable. So we are not going to keep this entry. We cannot simply purge it. So there has to be a timer associated. So for that time, I am going to keep the entry. So 0, 1, 2, 3 will keep the entry for this timer, and after that timer it will check whether that entry is, if I search for this entry, if I search for 0443, whether I am able to get the response from 090F. If I am able to get it, it means this has been safely stored there, and this time is sufficient enough so that 090F has already created a backup by this time. And at this moment, I will be able to purge. If I am successful, purge if successful in getting key value pair, and which is same. Okay, and suppose if it can come back again, by the time you find if this scenario is going to be there, the scenario 2 will be happening in this case. So you won't be able to, it will be a failure when the verification happens. So you will again do a publication, again do the republication. And if it does not die off, and next timer will be reset again, the node does not die off, this time you will be 100% getting a success. And then you will be doing the purger of the entry. So this is the way the thing actually should happen, and we can maintain, any new node comes in, the key value pairs will always move towards the correct root node. Key value pairs will all be moving to correct root nodes. Now only problem which remains is now if the node dies off, what is going to happen? So in this case, we need to figure out a mechanism for this. So one possibility is somehow the source will figure it out and he will republish, who has published this key value pair. But that probably source is dead after putting the key value pair. It's a responsibility of DHT network to ensure that reliability is there. So resilience has to be part of DHT mechanism. How that will be handled? So in this case, let's see how this is going to be done. We will do it in so basically somehow we have to make sure that there is not one copy. So either root node maintains some mechanism by which it is maintaining a backup copy, and if it dies off, that backup copy surfaces back and then gets restored in whatever is a new root node. There will be some new root node, it gets installed there, and this then further maintains the backup. In case if again fails, it is going to do this, and if this node comes back again, this node comes back again, then this has to go back, this entry has to be restored back to this new node. So which anyway is now being done. Currently if a new node comes in, an entry has to move there, that we are anyway ensuring in the current mechanism. So in the next lecture we will be looking at the mechanism by which this resilience is going to be provided. There are actually few mechanisms, few methods which can be done. Any one of them can be used. In B4 we are choosing only one particular specific method to provide the resilience.